Page 67, last page of the book. Well done for getting this far. Right, a skier is going down a slope and reaches a constant velocity. That's important. Draw a force diagram for the skier. So let's identify the system. Gravity on skier by the earth. There is a normal force on skier by the slope, the snow. And he's going at a constant speed. So if I was to just draw these in my vector addition diagram so far, they don't end up back where they started from. They need to for a constant speed for it to be net force zero. There must be something pulling back up the slope. Now, if I was marking the exam here, this is a question exam, I wouldn't be too tough on what you chose this to be. It's definitely some sort of friction force. It's definitely on the skier. But if you decided to say it's by the snow, or if you decided to say it's by the air, I'm not worried. So why don't we just say air? But you could have said snow. Okay, we've got this guy here. Determine the skier's weight. That's another name for the force of gravity on the skier. And that is equal to their mass times the gravitational field strength, which is 90 kgs times 9.8 newtons per kg, which equals 90 times 9.8, 882 newtons. My 8s were bad. Let's do them again. You could, if you want, say 880 newtons to two significant figures, but usually in my intermediate answers, i.e. not my last answer, I keep it pretty exact so that it carries through well. And then the last answer is usually when I do my my rounding. Determine the normal force on the skier by the hill. Let's draw our vector addition diagram again. -35-degree hill, normal force, force of friction. Really important you put how that's the 90 degrees in there. Which one of these is the 35? Remember, my trick is if I was to make it not 35 degrees, like 3 degrees, and drew my force diagram for that, then when I put them together, one of these angles is tiny. The angle that's tiny is this one. And so this is actually my 35, and then this is, what was it, 882. The normal force. So 35 is here, opposite the 90 degrees is the hypotenuse. Beside the angle we care about, the 35 is the adjacent. Opposite the angle we care about is the opposite. When we want the normal force, we want these two. And that is SOHCAHTOA. I've got hypotenuse and adjacent. And so that's cos 35 equals adjacent Fn over 882 times both sides by 882. I get 882 times cos 35 equals, on my calculator, 722 newtons. Determine the force of friction and air resistance acting upon the skier. Force of friction, there's the old 90, 882. I now know this one's 722, and this is 35. Now I could do a SOHCAHTOA to work this out, this last one out, the friction. But I could do it a different way. I could do my Pythagoras, a squared plus b squared equals c squared. So let's change it up just because we can. This is my a, here's my b, and the hypotenuse is always c. So I want to find a, so I'm going to minus b squared. A squared equals c squared minus b squared. So a squared equals 882 squared minus 722. And I'm just going to put decimal points in because that can make a difference. 4921 squared. So that is on my calculator, 882 squared minus, I like using the answer button, answer squared. My calculator says 255,929.161. That's not the answer. It's squared. So this a squared is a force of friction squared. So square root both sides. So my force of friction equals square root answer. Oh, what happened there? 505.894 newtons. And then because it's my last answer, my question had a 35 degrees. It also had 90 degrees scare, so two significant figures. So rounding off to 510 newtons, there's my two significant figures. And that's what this says. Explain how you know. What I'm asking for here is that you realize that they're going at a constant speed. So we must have a closed vector addition diagram. Okay, that's my explanation. Great. Good job on getting that book finished.